Hi everyone, welcome to Ms. Sawagid's math class. Today we will be discussing transformation. And the first thing that comes in mind when we talk about transformation, how can a butterfly transform from a caterpillar into this beautiful butterfly? Or when bumblebee changes or transforms into a car and vice versa. In math, transformation is a little bit different because we're talking about how can we transform a figure in a coordinate plane. Transforming a figure means changing its size, shape, or orientation. Think about this umbrella as the transformation, and under it, the way we can transform a figure. The first one is translation. The second one will be reflection. The third one is rotation. And the last one is dilation. And those are the next four lessons we'll be talking about to transform a figure in a coordinate plane. So now we will be discussing something called translation, which is the first way to transform a figure in a coordinate plane. But before we move on to the coordinate plane, let's talk about examples of translation in real world. Tessellation is created when you repeat a shape over and over to cover the surface without any gap or overlay. And you can tell the cubes being repeated or slided to the right or down to create this beautiful tessellation. Or when you're building a brick wall. Now let's review what is a coordinate plane. What is a coordinate plane? Look at this graph. This is called a coordinate plane. And if you can see, it has the x-axis that works as a number line. If you go to the right, you have the positive x. You go to the left and you got the negative x. Or the vertical line, which is the y-axis, if you go up, it has the positive y. And if you go down, it has the negative y. Because of those axes, we created 4 quadrants. And it starts with the first quadrant, which is the first one, where x is positive and y is positive. If you go counterclockwise, you end up with the second quadrant where x is negative and y is positive. The third quadrant, the x is negative and the y is negative. In the fourth quadrant, where x is positive and y is negative. Any coordinate pair lands in any of those quadrants will follow the same sign. Now, right in the middle, the yellow dot is called the origin, where the number line starts for the x-axis and the y-axis, which is 0, 0. Now, let's practice graphing this coordinate pair, a, -2, 3. You always start from the origin, and just like kids, they learn how to walk before they learn how to jump up and down. So start from the origin. The first number is always the x, the second number always the y in the coordinate pair. So start from the origin, walk on the x-axis to -2, and then jump up to +3, then put that red dot and name it A. That's how you graph coordinate pairs on a coordinate plane. Okay, now we said translation is sliding. I want you to grab a book and see if we can slide this book. And I chose a Toy Story book. I want you to slide this book to the right and up. And now answer the questions. Did the size change? No, it's still the same book. Did the shape change? No, it's still the same book. Did the orientation change? No, because it did not turn, so it stayed vertically up. So what did change? What kind of transformation took place? Only location. It was here, and after sliding it or translating it, it went up to be here. This is the original, and after the transformation or the translation, it's called the image. So the image and the original are congruent because all corresponding sides and all corresponding angles are congruent. So translation is a form of transformation that proves congruency. So translation is sliding. Translation is a transformation which a figure slides but does not turn. Every point on the figure moves the same distance in same direction. An algebra rule that you will be using to graph each coordinate on a coordinate plane from the original to the image, you will be using this, x and y, which is the original, to translate that point some distance, some direction, x plus a and y plus b. The plus gives you the direction. If it is plus, means you're going right, and if it's a minus, you're going left. And a is the distance. With the y plus, the plus means you're going up, and the minus means you're going down on the y-axis, and b is the distance. Okay, now let's translate this triangle according to this rule. The translation means slide, x plus 3 and y minus 2. X plus 3, that means x is increasing by 3, which means you're going to the right. And y is decreasing by 2, which means you're going down on the y-axis. So here's the triangle for you to see it. This is the original triangle, A, B, and C. I'm sliding this to the right 3 and down 2. Each vertex has to go to the right 3 and down 2. So go 3 units. 1, 2, 3, and down 2, 1, 2, and you will end up right over here. That's the image. The original and the image are congruent because corresponding angles are congruent, did not change. Corresponding sides are congruent, they did not change. So corresponding angles and corresponding sides are congruent, therefore the two triangles are congruent. So now that's one way to translate the triangle, is to count spaces. So what are the coordinates of the image? So I'm going to take this triangle down and now write the coordinates of the image. This is where you landed. You went to the right 3 and down 2, you end up here. And the coordinates are 8, 6 for B prime, and A going to the right 3, 1, 2, 3, down 2, and you end up here. And the coordinates for A prime is -7, 6. And the last one is C, going to the right 3, down 2. You end up here, and C prime will be 8 and -9. Now let's see, following the rules, would it give me the same results? Because you can count spaces. Here's the new triangle. This is your new triangle or the image after the translation. Now let's use the rule x plus 3 and y minus 2. Substitute x with -10 plus 3, and the y is 8 minus 2. -10 plus 3 is -7, and 8 minus 2 is 6. Did I get A prime -7, 6? Yes. Now B, 5 and 8, so x is 5, 5 plus 3, and the y is 8 minus 2. You end up with the B prime, which is the image. 5 plus 3 is 8, 8 minus 2 is 6. Is B prime +8 and 6? Now C, 5 and -7. 5, the x, add 3 to it, and y -7, subtract 2 from it. So 5 plus 3 is 8, and -7 minus 2 is -9. Is that where C prime is? 8, -9. That's a translation. You can count spaces, literally counting spaces on the coordinate plane, or using the rule to add and subtract if needed. I wanted you to see the original triangle A, B, C, and the image A prime, B prime, C prime. That's why I had to draw it better. So now I can conclude that triangle A, B, C congruent to triangle A prime, B prime, C prime, because it's only a translation, proves congruency. That's it for today's lesson. Thank you for listening.